Hey, Mr. Sam.
Hey, wow, you are fast.
Well, you know, I like to measure myself all the time.
Oh, yeah?
Not like how tall I am, but I like to measure how fast I am.
Ah.
Because, you know, I am fast. Because I always train for these stupid, well, they're not stupid, they're great triathlons. So today we're going to talk about measurement and how you can measure things, measure how fast something moves, or like, how am I fast, or am I moving at 5 miles an hour, or 6 or 7 or 8 or whatever. So today we're going to talk about measurement and the importance of measurement. Hey, today we're going to talk about measurement.
Yeah.
Yeah, you saw me running fast right there, and which is a certain kind of measurement. And then we're going to talk also about when you can measure that amount,
with
like numbers.
Yeah.
And then also we're going to talk about scientific notation. So that's kind of fun. How do you deal with really big numbers, like when I'm going really, really fast?
Yeah.
Yeah. So that's what we're going to talk about today. Okay.
All right, we've got 3 candles in front of us. We're going to do look at some types of measurements on these candles, quantitative and qualitative measurements. So I just told you there are 3 candles. That's a quantitative measurement because that talks about a quantity.
So it's like a number, isn't it?
It's a number. Quantitative measurements have a number.
That's
on
cool.
So 3 candles. Now I could also take my little ruler here and I could measure this candle. Okay, this candle looks like it's about, I don't know, a little over 10 centimeters. So that's a measurement. I could measure this one. This one is 4 centimeters. So this one, 10 centimeters, 4 centimeters. Those are quantitative.
I would just like call it the tall candle.
Yeah, or the tall candle and the short candle. That's qualitative measurement.
Okay.
Okay, no numerical value assigned to that. Now this one is wider than the other 2.
Fat one.
It's the fat candle. Okay, so that's a qualitative measurement. This is the skinny candle, qualitative measurement. Or I could measure it. This one, it's about 4 centimeters wide, and this one's about 1 centimeter wide. So that's a quantitative measurement. Now, you could use a thermocouple and measure the temperature of the flames, and then I'm not actually going to do it because this isn't a thermocouple. I'm going to pretend, but that would be probably about 500 or 600 degrees Celsius. All the flames could be, so that'd be a quantitative measurement. I could measure a numerical.
So it sounds to me like quantitative have like numbers involved.
If you have a quantitative measurement, you have a number. Qualitative measurement, you're making a quality assessment about something. We could talk about color. This is kind of a yellow candle versus.
So it's like Mr. Bergman is fast. That would be like what?
That's a qualitative measurement.
Now, Mr. Bergman ran at a 6 minute per mile pace.
Yeah, that's a quantitative measurement.
I see. Got numbers. Yeah.
Yep.
All right.
You know, Mr. Sam's is devilishly handsome. I think that'd be a qualitative measurement. You don't like that one?
Well, you are devilishly handsome. You are a hunk, Mr. Sams.
Exactly.
Woo!
Oh yeah.
Check out you. My gosh. Look at that. Ooh, yes. Okay.
All right.
You got it? Qualitative, descriptive, quantitative, mathematical.
There it is.
Numerical. Thanks. So, Mr. Sams, when we're measuring things, sometimes the numbers get really, really big. Mm-hmm. And?
Sometimes, especially in chemistry.
Really, really small.
Yeah.
And you see, scientists are tired of writing all
lazy. Chemists are lazy.
They're trying to come up with a better way of writing down numbers, and the way we use is something called scientific notation. So why do we use scientific notation?
That way we don't have to write all those stinking zeros before or after a number.
It has to do with really big numbers or really small numbers.
Yeah, and it also kind of has to do with the accuracy of our measurements, but we'll talk more about that a little bit later.
Yeah. So we want to deal with this concept. So let's kind of talk ourselves through this. So I have some things to measure, or measurements. I've actually I got off the internet, Wikipedia, I believe. The sun is a very big thing.
The sun.
Now the sun. Do you know the sun is a star?
I did.
I bet you did. I hope you did.
Yeah, my son knows that. My son knows the sun is a star.
But why is it so bright compared to like all of the other stars in the sky?
We're really, really close to it.
Yeah. But you know the sun is huge. In fact, it is. It looks like 1.392 million kilometers in diameter.
It's big.
So if you draw a line across, this line from here to here is very big.
Yeah.
So, but we, instead of saying 1,392,000 kilometers, we would like to write that in scientific notation.
Yes.
So how do you do that, Mr. Sam?
Well, you take all the numbers that aren't zeros, and you put a decimal between the first and second number.
So that would be between the 1 and the 3.
Right, that's where a decimal point's going to be.
So you'd say 1.392. Now, do you use these zeros here?
No, you don't write those down.
Yeah, you wouldn't actually. So, and you'd say
times 10 to some power. Now, to figure out the power, you go from where the decimal would have been.
1 to the end, right?
2,
3, 4, 5,
6. We moved it 6 places, so that's 10 to the 6th power. Okay.
There you go.
Yeah.
That's pretty easy.
It is.
Now, I bet most of you have seen this before, but it's kind of a review. And if you haven't, now you get to learn it.
Yeah.
Now, there's also like small numbers.
There's small numbers.
So this right here is the diameter of a typical nucleus in an atom. Now, atoms
Okay.
are really, really tiny things.
Really tiny.
And it is 1.6 times 10 to the minus 15th meter.
Oh,
That's
wow.
a small
That
number.
is small. Now, that
Now-
one's in scientific notation.
Yeah, it's in scientific notation, so we
Okay.
need to see if we can write this in sort of what we call regular notation, or
Okay.
a regular number.
All right.
Now, so what do I do here?
Well, you've got the 1.6, so we're going to have a 1 and a 6 together.
Yeah.
And we're going to have to move the decimal point 15 spaces to the left.
So we're going to start this number and go 0. Now I want to start counting. I need to
Yep.
go 15 places,
Right.
sort of. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12,
Uh-oh.
13, 14.
1, 6.
Now the 15th one, this is tricky.
Right.
1.6 meters.
Right.
Now this right here, the 1 is your 15th place. You don't have 15 zeros.
Right.
You have 15 places.
Right. So if you want to double check your work, just take your decimal and kind of move it along
Yes.
the zeros, and if it
1,
lands,
2, 3, 4, 5, da, da, da. You should end right here.
should land between the 1 and the
1 and
6.
That'd be
Right.
your 15th place.
Exactly.
Okay.
Now notice that things with a positive exponent are
Yes.
big numbers greater than 1, and things with negative exponents are small numbers, numbers less than 1.
So small, the zeros are in front,
Yep.
and big, the zeros are behind.
end.
So here's another big number. This is the speed of light. So light travels pretty fast. Zoom! Very, very fast.
That was fast.
That was fast.
That was.
Actually, it's faster than that.
Yeah.
Yeah.
Here, let me see the pen.
Oh, okay.
If you take the when we draw, where's my pen? There it is. You can put the little speed. Whoosh, whoosh. It means it's going really fast.
Oh, I got
like on
you.
cartoons.
Yeah, there you go. So
Yeah.
the speed of
The
light.
speed lines at
Okay.
the end of something.
This number looks like it
Really
needs to be put in
fast.
scientific notation, Mr. Sands.
It does. It's
So-
too big. I don't like big numbers.
So the decimal goes between the 2
Between
and
the
9.
two, yeah, so 2.98.
2.98 times
And then we count how many spots
places.
went there.
1, 2, 3, 4, 5, 6, 7.
7.
That'd be 7
That's
meters
not
per
right.
second. Isn't it times 10 to the
It's
8th?
times 10 to the 8th. I think your number's wrong.
I think this is supposed to be
I
a
think
0.
we're missing a 0 there.
All right, I know it's 10 to the 8th meters per second. So pretend there's an extra 0 there.
Yeah.
Because actually I know that answer. Okay, and then one last one. The mass of a proton.
Ooh.
Oh, that's a nasty number.
That's a lot of zeros.
So one proton. What is a proton, anyways?
It's
What
a
that got?
positively charged particle in the middle of an atom.
So yeah, in the middle of an atom
nucleus.
there's a nucleus, and inside the nucleus is protons and actually neutrons as well. And so if I was to say, well, how big is a neutron, a proton, and this is the size of a proton, or the mass of a proton, I should say. Now, the first non-zero digit is that 1. So between the 1 and the 6 is where my decimal point is.
Yes.
So I'll say 1.673 times 10.
Now it's going to be a negative exponent because this is a small
1,
number.
2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That's the right answer. Times 10 to the minus 27th kilograms.
You knew that one off the top of your
I
head?
did know that by the top of my head, yeah.
He does that, folks. He'll just pull these numbers out of who knows where, and it's like, where did those come from?
I've seen them for too many years. Okay, so I'm old, yes, indeed. Okay, so that is how you would do that. Pretty
All right.
easy, right?